Steel cables are one of the most important industrial materials in the modern world. From giant suspension bridges, skyscrapers with millions of people moving by elevator every day, to the mining industry, offshore oil and gas, and renewable energy, steel cables are everywhere. Thanks to their special properties, this material has become a solid foundation for global infrastructure and industrial development. What makes steel cables different is the ratio of load-bearing capacity to size. Although only a few centimeters in diameter, a steel cable can withstand hundreds of tons of load while maintaining stability. The structure consists of hundreds, even thousands of small steel wires twisted tightly together to distribute force evenly, creating flexibility while maintaining enormous load-bearing capacity. Thanks to that, steel cables not only last for decades but also adapt well to harsh conditions such as high humidity, marine environments, or extreme temperatures. The importance of steel cables has become even more evident in the era of industrialization and urbanization. Without them, iconic structures such as the Brooklyn Bridge, the Eiffel Tower, or giant oil rigs would hardly exist. Today, millions of elevators, transportation systems, and global renewable energy all depend on this material. It can be said that steel cables are one of the silent heroes that keep the world running safely and sustainably. Steel cables, a seemingly familiar material, have a history closely linked to the development of modern industry. In the 1830s in Germany, when the mining industry entered a boom period, traditional hemp ropes were no longer able to meet the needs of lifting and lowering huge loads in mines hundreds of meters deep. It was in this context that the first steel cables were born, completely replacing natural fiber ropes that quickly rot and break easily. This invention quickly opened a new era. Thanks to its outstanding load-bearing capacity, steel cables have helped make mining safer and more efficient, and at the same time become the foundation for many other industries to develop. From coal mines, construction sites, to transportation systems and suspension bridges, steel cables have gradually asserted their irreplaceable position. Over nearly 2 centuries, steel cables have been constantly improved in production technology and quality. From the original crude cables, today they are manufactured with modern processes, steel refining, precision wire drawing, heat treatment, and anti-corrosion coating to be able to operate in the harshest conditions. Currently, the world consumes more than 10 million tons of steel wire rope each year, spread across many fields such as infrastructure, renewable energy, marine, oil, and gas exploitation, and millions of elevators in urban areas. This proves that from an emergency solution in 19th century German mines, steel wire rope has become a silent pillar of the global economy. To produce durable steel cables, the journey begins with the basic raw material, iron ore. This is an abundant mineral in the Earth's crust, often concentrated in open-pit mines or deep underground mines. The iron ore mining process often applies modern technology, combining drilling and controlled blasting to break up solid rock blocks, creating conditions for large tonnage excavators to collect and transport. After being mined, raw iron ore cannot be sent directly to metallurgy. They must go through many preliminary processing steps to increase the iron content and remove impurities. First, the ore is crushed into uniform particles, making it easier to select. Next, the ore goes through a screening system to separate by size, then uses magnetic separation technology to separate the iron from worthless rock. Thanks to that, the final product meets steel-making standards while reducing costs and energy for the following stages. Once refined, iron ore is transported by specialized trains or large ships to steel-making complexes. This is the core material for producing steel billets, then drawn into steel wire and twisted to create high-quality steel cables. Thus, from seemingly lifeless rocks underground, iron ore has undergone a sophisticated mining, screening, transportation process, becoming a solid foundation for the formation of steel cables. A material that plays a vital role in modern industry. After the iron ore is processed and brought to the factory, the next important step in the journey to create steel cables is steel smelting. This is the stage that determines the quality, durability, and applicability of the final product. In modern factories, steel is often smelted using electric arc furnaces, an advanced technology that uses extremely strong electric currents to create temperatures of nearly 3,000 degrees C. At this terrible temperature, iron and other components quickly melt, separating from impurities. This is a favorable environment for engineers to adjust the chemical composition of steel. To improve mechanical properties, people add alloying elements such as manganese, melurine, to increase ductility, chromium Cr, to improve rust resistance, nickel, Ni, to increase impact strength, and silicon Si to support wear resistance. At the same time, slag-forming agents are added to absorb impurities and sulfur, making the steel cleaner and more uniform. After the refining process, the molten steel is poured into molds or continuous casting systems to form steel billets in the shape of bars, plates, or ingots. This is the intermediate material, which will later be rolled, drawn, and made into steel wire used in the production of steel cables. Thanks to the combination of advanced metallurgical technology and strict control of ingredients, the finished steel not only achieves outstanding durability, but also has the ability to withstand force, resist corrosion, and maintain a life of decades in harsh environments. After being refined in the electric arc furnace, the molten steel will be transferred to the continuous casting system. Here, the steel is poured into special molds to form steel billets of different shapes, such as billets, square bars, slabs, large plates, or blooms, rectangular bars. This is the basic source of raw materials for the next processing stages. Once the billets have cooled to the appropriate temperature, they are passed through the hot rolling line. Under the impact of giant rolling rollers, the steel is pressed and stretched into steel bars, steel plates, steel coils, or round bars. This process not only shapes but also helps the steel have a more uniform grain structure, increasing its bearing capacity and mechanical strength. The steel casting and rolling process plays a fundamental role in the metallurgical industry, because from these billets and rolled products, steel can continue to be drawn and braided to create super durable steel cables for construction, mining, and a series of other industrial fields. From the hot rolled steel bars, the steel wire drawing process begins. The steel bars are passed through a drawing die system with diameters gradually decreasing, helping the steel from its raw form to be stretched into thinner fibers. Thanks to that, the steel can reach a size of only a few millimeters, but still maintain very high mechanical strength. During the process, technical factors are strictly monitored. Modern lasers are used to continuously measure the diameter of the fiber, ensuring almost zero error. At the same time, the system automatically adjusts the pulling force and pulling speed to avoid cracking, keeping the fiber surface smooth. The drawing stage not only helps the steel reach the correct size, but also improves the uniformity, load-bearing capacity, and ductility of the material. This is the premise for the steel wire to move to the twisting stage, creating steel cables with huge load-bearing capacity, serving key projects such as suspension bridges, drilling rigs, or offshore wind turbines. After the steel is drawn into thin strands, the next step is heat treatment to enhance its mechanical properties. The steel strands are fed into a furnace at high temperatures, then undergo a quenching process and are rapidly cooled using compressed air or specialized oil. This process allows the metal crystals to rearrange, providing the ideal balance between hardness and ductility, ensuring that the steel strands are both load-bearing and flexible enough to be twisted. Immediately after heat treatment, the steel is put into the anti-rust coating stage, an indispensable protective layer in harsh environments. The most common is hot dip galvanizing, which forms a durable metal coating that prevents oxidation. For special applications, the steel strands can be coated with polymers to resist corrosion from salt spray, seawater, or chemicals. Thanks to this protective layer, the steel strands can maintain their quality for decades. Even when working in humid environments, offshore, or in key infrastructure projects, This is an important stepping stone before the steel wire is braided into super strong steel cable. Before entering the braiding stage, the steel wires must undergo a rigorous inspection and classification process. A laser sensor system and high-resolution cameras continuously measure the diameter of the steel wire with an error of only 1/1000th of a millimeter. Any deviation is detected immediately. In parallel, the surface of the steel wire is scanned to detect cracks, deformations, or tiny rust. These are factors that potentially cause breakage during use. Next, random steel samples are put into a load testing machine to measure tensile strength and ductility. These data are compared with international technical standards to ensure absolute reliability. Substandard wires are immediately removed to avoid affecting the quality of the finished cable. Only uniform wires, smooth surfaces, and optimal strength are transferred to the braiding stage. Thanks to this rigorous grading process, each completed roll of steel cable is of the highest quality, ready to serve in infrastructure projects, bridges, and important industrial equipment. After passing strict quality inspection steps, qualified steel wires are put into the twisting line to form complete steel cables. In this stage, dozens, even hundreds of steel wires are twisted evenly around a central core. This core can be made of steel to increase load-bearing strength, or of synthetic fibers such as polypropylene to make the cable lighter and more corrosion-resistant. The braiding process takes place according to precise technical design, ensuring that the fibers are arranged in spiral layers. The outer layers protect against abrasion, the middle layer bears the main load, and the inner layer helps stabilize the overall structure. Thanks to this reasonable distribution, the steel cable is both flexible for easy installation and has the ability to withstand huge tensile forces for a long time. The entire process is controlled by a modern sensor system, automatically adjusting the twisting speed, tension, and braiding angle. Thanks to that, each meter of finished cable ensures uniformity, ready to serve in suspension bridge projects, high-rise elevators, or industrial projects requiring absolute safety. Once the wire rope has completed the twisting process, the next step is specialized lubrication to protect the internal structure and increase its service life. Lubricating oil or grease is applied evenly by immersion or high-pressure spraying, allowing it to penetrate deeply into the spiral grooves between the steel wires. This layer of oil reduces friction when the wire rope is operating, limits wear, and prevents the penetration of moisture and corrosive chemicals. After the lubrication stage, the wire rope enters the final inspection round, a key step to ensure absolute safety before leaving the factory. Each batch of products is tested by a hydraulic puller to determine the maximum load capacity and undergoes multiple cycle bending tests to simulate actual working conditions. In addition, ultrasonic testing and laser sensors are used to detect cracks, deformations, or the smallest dimensional errors that are invisible to the naked eye. Only cable reels that pass all stringent technical standards are packaged, labeled with batch codes, and shipped to global customers, ready to serve in projects requiring superior reliability and durability. After passing the final inspection, the finished steel cables are put into the automatic winding system. The giant cable rolls are wound evenly on steel or engineered wood pallets, ensuring that the wire is not slack, folded, or twisted. This process is monitored by tension sensors and optical cameras, helping each roll to be exactly in the right position, maintaining its shape throughout the transportation process. When the roll is completed, the product is wrapped in a layer of moisture-proof film or specialized oilcloth, preventing the effects of water vapor, dirt, and sea salt in the transportation environment. On the core of the roll, the factory prints the batch code, traceability information, and quality standards, making it easy for customers to check and manage. The cable rolls are then moved by cranes and automatic forklifts to the logistics area, where they are loaded onto specialized trucks or anti-rolling containers for transportation to construction sites, seaports, or global warehouses. Thanks to the strict and safe packaging process, Steel cables always reach customers in optimal condition, ready to serve key projects around the world.